This paragraph here is saying a common error in determining the limits is assuming you can always plug it in directly. So in example 4, if you plug in x equals minus 3 directly, you get 0 over 0, which tells you that x plus 3 is a factor on top and bottom. So if you get 0 over 0, you should be able to factor out a common term and cancel it and evaluate it. So what they're saying here is if I cancel out this x plus 3, I'm left with x minus 4. So the graph of this function looks like the line y equals x minus 4 everywhere x does not equal minus 3. At minus 3 it has a hole because it can never be minus 3. So what they're doing here is they're evaluating the limit at the right and the left of minus 3 because you cannot plug in x equals minus 3, but you can plug in numbers that are really, really close to minus 3 on the left-hand side and numbers that are really close to minus 3 on the right-hand side and see if they're equaling the same number. So when you do the algebra, you get x minus 4, and if you plug in x equals minus 3 in here, you're getting minus 7, which is the same value that the table gives you. Graphically, you can see that if I plug in numbers that are getting closer and closer to minus 3 on the left, my numbers are getting closer and closer to minus 7. If I plug in numbers that are getting closer and closer to minus 3 on the right, I'm getting closer and closer to minus 7. So that's kind of what they're showing here. But if you plug in minus 3 into the original function, you get 0 over 0. This is an indeterminate form, which we will later on learn that we can use L'Hopital's rule to solve that. Here's two examples in which the limit at a certain point may or may not exist, but it's not an indeterminate form. So here, if I try to take the limit as x goes to minus 3 of this function, if I plug it in, I have 1 over something. I really have 1 over 0. But I have to be careful because this is going to 0. And it turns out in this limit, graphically, if I plug in numbers that are getting closer and closer to minus 3 on the left, right, I'm always minus 3.0001. And if I plug in numbers getting closer and closer to minus 3 on the right, I look like minus 2.9999, so forth. If I plug in those numbers, if I plug in the minus 3, I'm going to minus infinity. If I plug in the minus 2.99, I'm actually a positive number going to infinity. So the limit here does not exist. But this example, if I plug in numbers on the left and on the right, they're always positive because of this squared. A negative number squared is positive. So it turns out on the left, the limit as x goes to minus 3 on the left of the function is positive infinity, and the limit as x goes to minus 3 on the right of the function is positive infinity. Since they equal each other, the limit at 3 of the function is positive infinity. So an indeterminate form would be something that's 0 over 0, and you can do algebra to factor it and get closer to the limit. Just because you plug in 0 over 0, that doesn't mean the limit's not going to exist. There's ways to simplify it algebraically. Or you can use a table or a graph to determine the limit. Later on, we'll use L'Hopital's rule. So a common error is just assuming it's not going to exist if it's 0 over 0. If you get a 0 in the denominator, then you know you have to do more work, that you're not completely done. But here we get a constant in the numerator and a 0 in the denominator. We have to check the right side and the left side. Here it doesn't exist. Here I have a constant over something going to 0, but it does exist. Checking the right side and the left side, they both go to this positive infinity, so it does exist. And you can also use a table and then say, okay, as I get larger and closer and closer to minus 3 on the left, my numbers get more and more positive, larger and larger. As I go to the minus 3 on the right, they get bigger and bigger and bigger. So my limit's going to infinity. You can do the same thing here. One's negative and one's positive. So the limit's not going to exist at the point because one's going to minus infinity and one's going to infinity, and they don't equal each other. So this is just saying if you get 0 in the numerator and denominator, you cannot make any conclusions from that.